Welcome back. So this week we've been digging through some pretty dense technical beta sheets.
Well, yeah,
And it's for a piece of technology that is, well, it's probably staring you in the face every single day.
right. It's that invisible infrastructure. You're looking at the screen, the information on it, but you never think about what's holding that signal together.
Especially in a place that's like actively trying to shake it apart.
Exactly.
And that's our mission today. We're doing a deep dive on a device with a very functional name, the NTI ST-M12VA-R-600.
It rolls right off the tongue, doesn't it?
It's an industrial VGA splitter. And I mean, VGA makes you think of the 90s, but there's a very good reason this is still running the show, right?
Oh, absolutely.
Yeah.
To get it, you have to picture the environment.
Uh-huh.
So imagine you're putting a digital sign inside a subway car.
Okay.
That car is vibrating for, 18 hours a day? It's rattling, slamming over track switches.
Mm-hmm.
If you used a standard HDMI or a VGA cable, the kind you have at home,
Yeah.
it would shake loose in 10 minutes. Guaranteed. The connection just relies on friction.
So the old tech is actually the feature here.
In this world, yes. This NTI box uses something called an M12 connector system.
M12.
Right. So instead of just pushing it in, the connector is circular and it's threaded. You literally screw it into the port.
Oh, so it's physically locked.
It's effectively fused to the box.
Yeah.
The data sheet is really clear on this. It's vibration-proof and water-resistant. So when that train hits a rough patch, the screen saying, "Next stop," doesn't flicker.
That explains the ruggedized part. The casing isn't plastic either, is it? It says rugged steel with a powder coat finish.
Right. It's a tank.
But I'm looking at these temperature specs. -4 degrees Fahrenheit to 158. That seems like overkill.
You'd think so, but it's about continuity. That train sits in a freezing rail yard all night in the winter,
Or bakes on the tracks in the summer.
or inside a steel mill. Consumer electronics just aren't built for those temperature swings. The components expand and contract, and eventually a connection just breaks. This is built to survive that.
It also mentions immunity to electrostatic discharge, ESD. That's just static shock, isn't it?
Well, yes, but the stakes are much higher here. Imagine someone in a wool coat touches that screen on a dry day.
Zap.
A big zap. In your house, it's annoying. In a public system, that voltage can travel down the wire and fry the main splitter for the entire train car. This is hardened to just absorb that shock.
Okay, so it's a fortress. But what about the signal itself? This thing can send video to, 16 different screens? How far can you push a VGA signal before it just turns to mush?
That's the age-old problem with copper, yeah. The spec sheet says this unit can go up to 600 feet. That's about 183 meters.
Wow, okay. That's long.
It's enough to wire a whole factory floor or a very long train.
But you can't cheat physics. There has to be a trade-off.
And there is. It's resolution. So the short distance, maybe 100 feet, you're getting a really sharp 1920 by 1440 picture.
It's pretty crisp.
Yeah, you can read fine print. But if you push it all the way out to that 600-foot limit, the resolution drops. It goes down to 1024 by 768.
Which, for a sign that just says arrivals or caution, is perfectly fine.
It's more than adequate. And there's another clever thing here. We saw it has terminal blocks for stereo audio.
Oh, so you can do announcements too.
Yep. Since you're already running this one super tough shielded cable through the walls, you just piggyback the audio right onto the same run.
So you don't need a whole separate audio system.
It simplifies everything. One protected line, locked in with those M12 connectors, handling both sight and sound.
It really reframes what reliability means. It's not about the fastest chip. It's about the plug not falling out.
That's the soul of industrial engineering. The best system is the one that's still running a decade later, after being frozen, baked, and shaken every single day.
So a final thought to leave you with. Next time you're on a rattling subway car and you see a digital sign that's working perfectly, ask yourself, how much of our modern world depends not on being smart, but on a simple connector that just knows how to hold on tight?